Hello everyone, welcome back to our channel. And in today's video, we are going to solve a LeetCode problem called happy number. This problem will really help you practicing your skills with loops as well as using two-pointer technique, specifically speaking slow pointer and fast pointer. And at the same time, it will also test your ability with set data structures. So let's get started and delve into the problem. So here if you see in the problem statement, it says that you have to write an algorithm to determine if a number n is happy. Okay, so a happy number is a number defined by the following process. Starting with any positive integer, replace the number by the sum of the square of its digits and repeat this process until the number equals to 1. Or if it loops endlessly in a cycle which does not include 1. So those number for which this process ends in 1 are happy. So you have to return true if it ends in 1 or else it is false. Let's understand happy number with an example. Okay. So when the input is 19, so we have to determine whether it is a happy number or not. So when we find the sum of the square of its digits, so 1 square plus n square result in 1 plus 81 equal to 82, and then again further computing it, 8 square plus 2 square, right? 8 square is 64, 2 square is 4, 64 plus 4, 68. Okay, similarly 6 square is 36, 8 square is 64, 36 plus 64 is 100. Okay, finally 1 square plus 0 square plus 0 square. So this will result in 1. So we can say that after computing n, and at some point of time it results in 1. Okay, so that's why n is a happy number. Whereas if we look at another number called n equal to 2, so if we'll compute it and find the next state to be 4, because 2 square is 4, right? Similarly, if we'll compute for further states, then next state for 4 is 16, and the next state of 16 is 37 by doing 1 square plus 6 square. So it will go ahead, and at some point of time its intermediate state would be 20, and if we compute this 20, then it will become 2 square plus 0 square, which will result in 2. So this is our initial number. So this 2 and this 2 is same, right? So since we have not reached 1, so we will compute again, but computing 2 square will result in 4. So this process will repeat, and we can guarantee that this will never result in 1, right? Because it's a cyclic. So that's why 2 is not a happy number. Okay, so that's our concept of determining whether it is a happy number or not. So if it is a happy number, we have to return true, and if it is a not a happy number, then we have to return false. Okay, so this is our problem statement. Okay, so now let's look at the approach to this problem. So we'll look at two approaches, and both these approaches are mostly same, but it will differ slightly. Okay, we'll look at the first approach. Okay, so in our first approach, what we will do is we'll make use of two pointer technique. Okay, so specifically fast pointer and slow pointer, and also by looking at the problem, we can clearly say that we have to compute the sum of the squares, right? So we have to compute sum of the squares, and we have to keep on doing that until we find 1. Okay, but at the same time we'll make use of two pointer technique to determine whether there is a cycle or not, like in this case, right? There is a cycle, correct? So there is a cycle here. Okay, so we'll have to determine whether there is a cycle or not. So let's look how we will do it. Okay, so here in the first example, these are our states, right? So what we will do, initially we'll have a slow pointer pointing to the start, and also we'll have a fast pointer. So what do I mean by fast pointer and slow pointer is, in each computation or in each iteration, fast pointer will move twice the speed of slow pointer. So what do I mean by this is, like initially slow pointer will be pointing to 19 and fast pointer is pointing to 19. So we'll compute and find our next state. In each iteration, fast pointer will compute its next state and it will compare it once again. It will compute once again and move to the next state. Okay, but slow pointer, it will just compute once, so it will reach here. So slow pointer will compute once, but fast pointer will compute twice. Okay, so here it will find that in first iteration, slow pointer will find that next state is 82 and fast pointer will find that my next to next state is 68. Okay, similarly in my second iteration, slow pointer will move one step ahead, but fast pointer will move two steps ahead. Okay, so at this point of time, we know that fast pointer has reached 1, so we say that it is a happy number. Okay, so why we are doing this? Mostly for detecting the cycle. So you'll understand it if we'll consider the next example, right? So let's take the second example. So in our second example, so if I write all the state like this, so initially our slow pointer will be pointing to the beginning of the array, and then in our next iteration, fast pointer will move twice. Okay, it will compute twice and find 16, and slow pointer will move just once. Okay, and again in next iteration it will move twice, so it will reach here, and it will just move once, so it will be here. So again in next iteration it will just move once, but it will move twice. Okay, and again in next iteration it will move just once, but it will first pointer will move twice. Okay, so at this point of time again slow pointer will move just once, 89, but here we can see that there is a cycle, right? So now when fast pointer will compute its next state, next to next state, so 20 would result in 2. So it will fast pointer will move twice, right? So it will point to 4. After 20 it will compute to 2 and then 4, but slow pointer will move slowly, so it will point to 145. Now again this fast pointer will move twice, here to here, and again this slow pointer will move just once, pointing to 42, and fast pointer will move twice, and again this slow pointer will move just once, pointing to 20, but fast pointer will move twice. Now slow pointer will move slowly just once, and next state of 20 is 2, but fast pointer here will move twice. So when it moves twice, it says that it's 20 and then finally pointing to 2. Okay, now when they meet, that is when the fast pointer and slow pointer pointing to the same number, that means we have detected there is a cycle. Okay, so that's how we use a pointer technique, specifically with first pointer and slow pointer technique, to determine whether there is a cycle in the list or cycle or not. Okay, so here we have clearly seen that fast pointer and slow pointer have met at some point of time, so we have a cycle. So and we can say that it is false. Okay, so that is the overall idea of our problem. We'll compute each state and we'll use 2 pointer to compute. Fast pointer will compute twice, but a slow pointer will compute just once. Okay, so let's do the coding for this problem. First of all, we need a function which can compute the square of its digits. So let me create that function first. I'll say that find square. Okay, and it will just take the number we'll have to iterate over each digit and find its square. So what I can do is num, and I can have a num string which will be the string representation of num, so that we can iterate now for each character in num, which is a digit, right? For each character in num string, what we'll do is we'll first find the integer form of the digit, and we need to hold a value for summing up. So what we'll say is sum of 1 plus equal to, so we'll keep on summing it up the square of that digit, or you can simply say the digit. Here I can say, instead of cs I can say the digit, and integer form of this digit, square of this digit is like this. So int of digit to the power 2 will be added to our sum, and finally we can return our sum. So that's how we have computed this. Now this is the function to compute square of digits. Okay. Now let's look at our main logic. So we need to have two pointer, first pointer and slow pointer. So I have sp comma fp, both pointing to the initial of the array 0 comma 0. Next we'll have to compute until either of them reaches 1, because in our this is the example where it will detect cycle, but there was an example where it will not be cycle, and there is a chance that we'll find a happy number. So when we will find happy number, either one of this pointer reaches 1. Okay, so we'll say that if so here slow pointer and f pointer are not just index. Unlikely in array we used to have pointer to pointed index, right? But here it will actually hold a value. It is in state, right? Fast pointer holds the value 2 or like that. So we'll say that while fp is not equal to 1, we'll run it, or sp not equal to 1, we'll run it. So if either any one of them becomes 1, then we can break it. Okay? That means when it came out of the loop, then we can surely say that either one of them have reached 1, so it is a happy number. So now inside this while logic, what we'll do is we'll find slow pointer, which will just compute once. So it will find a square, find square of, initially slow pointer and first pointer, when you said it is pointing to the head of the list, we're saying that it is pointing to n, right? So find square of slow pointer. So initially both slow pointer and first pointer value is 2 here for this example, and in this example it is 19, right? So next it is just doing this, find square of slow pointer, and fast pointer, what it does is self dot find square fp, but we'll do it twice, okay? Because we are saying that it will move twice, right? Or maybe instead of writing it twice, we can simply say that here, right? It will be like this. So it will find the fast pointer fp, and then it will once again find the square root digits of that value. Okay. So for example here, with this computation, this 2 would result to 4, but with this outer computation, this 4 would result to 16. So fast pointer would hold 16 instead of 4 because it moves twice. Now here, after computing, if SP and FP are same, right? Here, like for example, okay, instead of saying FP and SP is same, I'll say that either if SP is 1 or FP is 1. Okay, if either of that pointer reaches the value 1, that means we have found that it computes to 1 and it is a happy number, right? 1. And second condition is return true. And second is detecting cycle. We'll also write an if loop. Right? If SP is equal to FP. So at any point of time, if these two meets, right? Like in this example, we've seen that fast pointer and slow pointer meets here. Okay. If these two meets, then we have detected a cycle, and we can say that when it is a cycle, then it will never reach 1. Return false. So this is our logic to solve the problem. Let's run this. Let's submit this. Cool. So we're done with the first approach. Now let's look at the second approach. So in second approach, so computing the square of the digit remains same, but here what we will do is instead of using 2 pointers, we will use a set. Okay, so we'll make use of a set. So for example, here I have a set, initially I have a set of empty, okay, and what we'll do, we'll keep on computing. We don't have fast pointer and slow pointer, we'll just have an iterator which will keep on computing its next state, and while computing it will keep on storing this value. So it will store 2, and then second time it will compute 4, so it will store 4, and then it will once again it will compute, it will store 16, right? So it will keep on computing, and at any point of time if it reaches 1, then we are done, right? So see, in our previous approach also we had seen that if at any point if the value is 1, then we are done. But if it is not 1, and if there is a cycle, then we'll return false. But how to detect cycle? In fast pointer and slow pointer, we'll keep on, our approach was different, but for by using set, our approach is such that at any point of time, right, while computing, if it finds, while after computing, if it finds a value which is already there in set, that means it is a repetitive operation. That means there is a cycle. For example, after we'll keep on computing, and when we reach this 20, then we'll have all these value in our sets, right? 2, 4, 16, 37, 58, 89, 145, all these value will be in our set. So so here it will be 20, and then next time when it is computing, it will see that the value comes out to be 2, but 2 is already present here set. So that's why we can say that this 2 is already present, so there is a cycle and you can return false. So that's our idea behind the set. The benefit of using set is like to check whether a value exists in a set or not, just takes O of 1 time complexity. Okay, so each time we compute our next state, and see, before storing that value in our set, we'll see if that value is present in our set or not. So here in this example, we have computed 20 to 2, and then we check whether 2 is present in our set or not. And checking this just takes O of 1 operation, and then it finds that there is already a value of 2 in set, so it returns false. Okay, so that's our overall idea of using set. So let's code this. To code this, we'll just remove all this. Finding square logic remains same. So here we'll define a set. Okay, and then we'll compute the n and store it and store the next state in n only. So what we'll do is, while n is not equal to 1, we'll run it, and what we'll say that if n is not present in set 1, we'll run it. Okay. So n not in set 1. Instead of saying set 1, I will say that it is a sin set, right? So whether the value is sin or not. So if n not in sin set, then we'll run it. At any point of time, if the n value is present inside the sin set, then we know that it's a cycle, then we'll have to come out of the loop. Okay, or if the value is n equal to 1, then we found that it's a happy number, so we have to come out of the loop, saying that we don't want to check anything further. So there can be two cases. One is when n results in 1, and other is when n there is a cycle, that is n is already present in the sin set. Okay, so these are the two conditions where we'll come out of the loop. One is for true, like when n equal to 1, and one is for false, like n is present in sin set, and we'll have to say that there is a cycle. So here what we'll do, that if n is not in sin set, right, if n is not present in sin set, so we'll first add it in our sin set. Set dot add n, and after adding the value to sin set, we'll compute its next state. So our next state becomes self dot find square of n. Okay, so we'll do this, and we'll keep on doing until at any point of time n becomes 1, or n has been already visited, right? At that point of time, we'll come out of the loop, and when we come out of the loop, we'll just check that whether n is equal to 1 or not. Okay. If it is equal to 1, that means n has successfully computed to 1, and it results in a happy number. So we can say that it's a happy number. It will return true in that case, right? And if it is not 1 and is not equal to 1, that means there was some cycle, and it mutated. There was some cycle, so n value is not 1, and it will result in false. Okay. So that's our logic behind it. Let's run this code. Cool. Let's submit this. Amazing. So we have successfully solved our LeetCode problem of happy number. So this problem will really help you in interviews where you have to show your skill related to loops, right? Using two-pointer, specifically fast pointer and slow pointer, or showing your understanding of set data structure, right? How well you can use set. And also this will, by doing this problem, you will be in practicing these concepts, right? So in future, or at any point of time, if you are practicing any problem where you see you can apply this kind of method, then you can do that. Right? So now, if you have found this video helpful, then please hit the thumbs up and subscribe to our channel for coding questions and interview preparation. And if you have any question, suggestion, or confusion, then please put it in the comment box. and don't forget to hit the bell icon to so that you can see more such videos in the future. Okay, so that you can get a notification of such videos in the future. Thank you so much. I'll meet you in the next video. Thanks a lot.